Hello, you have your copy of a Jamboard, and you'll be reviewing the big ideas related to triangle congruence. On frame number 2, you have the first problem that you have to solve. There's a direction, there's a congruent statement that you have to complete, and a diagram. You'll be solving problems on frames 2 through 6, all related to triangle congruence. Here, you're identifying corresponding parts of these congruent triangles. On frame number 4, you'll be matching congruence postulates with a pair of triangles that matches the postulate. Frames 5 and 6, you are completing a 2-column proof. And to complete that 2-column proof, you can drag and drop these ideas onto your graphic organizer. When you get to frame number 7, you'll be ready to check your answers against ours. Go ahead and begin now and pause the video. Come back when you're ready. So let's see if your answers and our answers match, starting with frame number 2. Did you get that triangle QPW is congruent to triangle STW? And if I asked you what postulate could be used to justify that congruent statement, hopefully you would know side, side, side. Let's go on to frame number 3. And I have taken the liberty of using the congruent statement from the previous slide, writing it here in a text area, and I'm going to use not only the diagram, but this statement to help me find the corresponding parts. I'll show you what I mean. So angle P, it's the middle letter, is congruent to angle T, the middle letter. Also, the topmost angle, because you can see that this triangle is congruent to the other just by a reflection, right? So angle P is congruent to angle T. Angle Q is congruent to angle, base angle, first letter, S. Angle PWQ is congruent to angle TWS. Side PQ, it's the side that's marked with the 1 tick mark. It's the first 2 letters, is congruent to side TS. Side WP, the last 2 letters, congruent to side WT. And side WQ, the base, is going to be congruent to the base, side WS. Let's move on to frame number 4. Hypotenuse leg makes sense here because a hypotenuse and a leg of one triangle given as congruent to a hypotenuse and a leg of another triangle. Let's look over here. This one we've already talked about is definitely side, side, side. 3 sides of one triangle congruent to 3 sides of another. Now on this one, I'm looking at an angle, and then a side that follows, congruent to an angle, and a side that follows. So that one's going to be angle, angle, side. This one I have an angle, a side, and an angle. So this side is between the angles. I'm going to use ASA. And for this last one, we have angle, and then an angle, and then a side. So there's another AAS here. Because the vertical angles, we know these vertical angles are congruent. This is why we're using angle, angle, side. Frame number 5. We're proving that these triangles are congruent. I can see that it's going to be side, side, and then another side because QS is congruent to itself. Both triangles share QS. So we start by dragging over the given information. And the reason that PQ and RQ are congruent, that's given. Another given statement is PS and RS. QS is congruent to itself by the reflexive property of congruence. And now we have to decide which of these statements is correct. QPS, we're going down the side with 1 tick mark, then down the side with 2, has to be congruent to QRS. And that's by side, side, side congruence postulate. So these two are not used. Let's move on to frame number 6. How can we prove that these two triangles are congruent? We start with EF congruent to JH. That's given. There's another piece of given information that this angle E is congruent to angle J. Now by vertical angles, we know that this angle is congruent to that angle, but to avoid confusion, we're going to use 3 letter names for the angle. EGF is congruent to JGH. And that's by vertical angles. And now our congruence postulate. Which of these two postulates can be used? G, E, these are angles. So I have angle, angle, and a side. Angle, angle, and a side. So we're going to use angle, angle, side. And we're going to say EFG, starting at the marked angle, going down the marked side, landing at G, is congruent to triangle JHG. How did you do with that?